I'm building this carbon dioxide sensor project using a Senseair K30 sensor that will likely never be exposed to outdoor levels of carbon dioxide. During this process, I learned that these sensors usually assume they will be exposed to atmospheric levels of CO2 to do a type of self-calibration. I needed a way to turn this feature off, and I found one. And I learned a little about RS-485 along the way. Hi, I'm Alex doing Alex Things, and today I'm going to show you how I disabled the automated baseline calibration algorithm on my K30 sensor. I'm not a professional, just a hobbyist, and I'm sure there are other ways to do it, but this is the way that I did it. Let me shut off the power and remove the K30 sensor from the project. So if you can see here, this right here is the UART portion. And I just soldered on these little single row headers, or 2.54 millimeter. Just got these off Amazon. These wires here that I soldered on, these are for the I2C connection. And I just soldered them on. This was before I knew that the sensor had a baseline calibration feature that I knew I'd have to turn off. So I just hard soldered them to the board. But these little connectors really make it easy to fit some of these 22 gauge wires into them. I found this great blog post by a pretty neat electronic sensor company called CO2meter.com on using RS-485 and gas sensors. This post details how to hook up your K30 sensor's UART to a RS-485 transceiver, which you can see here. So the K30's UART goes to this RS-485 transceiver based on the MAX 485. And then from here, it's going to go to a USB to RS-485 FDDI adapter that's going to go to your computer. Some elements of how to do this aren't very clear from the diagram, and unfortunately the video was unavailable. So I wanted to figure this out for myself, but there are a lot of really good links in this blog post, like this one here. It talks about the USB converter adapter. There's sample codes for Pi, Arduino, and it kind of goes over the RS-485 protocol. A lot of really good information in here. And to communicate with mini gas sensors, CO2meter.com has a free downloadable software called GasLab that you can actually use to log and display the sensor data. Now, though I'm going to be using individual 7-segment displays for my project, the neat thing about GasLab is there is a Configure Sensor tab where you can actually disable the K30's ABC setting, and I'll show you how to do this in a few once we get it all hooked up. I'd also like to add that there's probably a way to simply write to the proper register on the K30 via I2C or Modbus or something like that and accomplish the same result directly, but I haven't got that advanced yet, plus this was an opportunity to learn about RS-485. To support that thought, according to this document by Senseair, on page 19 down here at the bottom, it actually gives you instructions on how to read the ABC period, and importantly for me, how to disable the ABC function by setting it to 0, and it actually gives you the register address of 0x001F, and kind of how to do that. There's a lot of really good information in here. I'm not quite at the level where I necessarily know what to do with all of that, but let me show you a diagram of how I hooked everything up. So here is the schematic drawing of how I hooked all this up. Now, one thing you're going to notice right off the bat, I have a breadboard in here to make the power connections, and I was also hooking up some other test stuff. I'll explain that in a minute. But the basic components are your RS-485 to USB adapter, which is this here. Then you have your RS-485 transceiver, which is this here. And then we have our K30 CO2 sensor, which is this here. And You connect the power, the plus 5 volts out from the USB. That's going to go to the VCC pin on the RS-485 transceiver, and it's also going to go to the G plus pin on the UART section of the K30. You can also power it through the I2C side. I already had wires soldered up for that, so I mean that'll work too, but I would stick with all the UART sides just so you don't get yourself confused. Then the data minus from the USB goes to the B side of the RS-485. The data plus goes to the A side of the RS-485. Ground obviously goes to ground on the RS-485 transceiver and goes to ground on the K30. Then this is where I got a little confused. To go from the RS-485 transceiver to the K30, you have 1, 2, 3, 4 pins. And on the K30, you have TX, RX, and RT. What these pins stand for: DI stands for driver input, that's a yellow. DE stands for driver enable, green. RE stands for receiver enable, also green. That'll be important in a minute. RO stands for receiver output, it's blue. Then, like I said, over on the K30, you've got TX, which goes to the DI pin, RX, which goes to the RO pin, and RT, which goes to both the DE and RE pins. So yeah, that's what confused me, because you have 4 pins here, 3 pins here. I mean, where does the other one go? So the way this works is for half duplex, which is communication in both directions, but only one way at a time. You need the driver enable pin to go high whenever you want to send data from the K30 to the computer through the transceiver. So when the DE pin goes high, any data that's on the DI pin, which is connected to the transmit pin from the K30, any data that's on the DI pin gets converted to RS-485 on the A and B pins, which goes to the USB. And when you want to go the other direction, the receiver enable pin has to be low. And when that's low, any data that's on the A and B pins of the RS-485 transceiver gets converted to UART on the RO pin, and that goes to the receive pin on the K30. That's why you have to tie them together, because you're doing half duplex. Most of the time, the K30 RT pin is low unless it's transmitting. I hooked this up to my analog oscilloscope when I was trying to wrap my head around how this all worked. And I noticed whenever it was reading a sensor value to the computer, I would see a blip of a positive voltage on the oscilloscope. It's really hard to see digital signals like this on an oscilloscope, especially if you're not good at the triggering controls, which I'm not yet. So a better way to see how all this works is to hook it up to a digital logic analyzer, which is what this guy is. And that's why you see this mess down here. I got this off Amazon, super cheap. And I'll show you what I did with that and the results from that. So here's the result of one complete communication between GasLab asking for a CO2 reading and the K30 sending a CO2 reading. One thing I want to add that I mentioned earlier, that it's hard to see these signals on a oscilloscope. I have an old analog oscilloscope. I think most digital oscilloscopes nowadays come with these kinds of features where you can record and freeze and store all this information. But for me, since I just have the old analog style, this was super helpful. So you can see over here, I named each of these pins after what it is. So this is the TX pin of the K30, this is the RX pin of the K30, and this is the RT pin of the K30. So you can see that most of the time the K30 RT pin is low. It receives I guess you could call this a packet of UART information on its RX pin, requesting a CO2 value. And then when it goes to send that value, because remember the DE pin has got to go high to convert the signal from the UART through RS-485 to the computer. So that pin goes high. It sends its, I'm gonna call it a packet, and that then goes through, gets transferred to RS-485, and then goes to the USB to your computer and to GasLab where it interprets it. This stuff is really cool. This SIGROC Pulse View is what it's called. It's a free download. It's a super cool addition to have. I don't really know necessarily what I'm doing with it. One of the things I messed up right out of the gate was I had all these, I think they're called frame errors on this, and I neglected to realize that the baud rate, you can set it. I also kept confusing the RX and the TX pins. So if you click on this here, you can actually change the names of these things, and you can set everything. There's a whole lot more settings that I honestly don't know what they do. But yeah, so this is super helpful. And it just goes to show that the RT line sits low most of the time when it's receiving, but when it goes to transmit, it goes high. And this was that blip that I was seeing on the oscilloscope. And it happens really fast. As you can see up here, here's the time scale. So since you probably don't have GasLab downloaded, just go to co2meter.com, type in GasLab, and it'll come up with the GasLab data logging software. Scroll down here to click to download software. And right here, they do have a quick start guide and a user manual. And one thing I want you to be aware of, it says to install this software before connecting your CO2 meter product to the computer. I guess this has to do with the USB driver instruction. I didn't have any issues with this. I did read a little bit of the user manual. It's actually really good. So yeah, get that downloaded, and then I'll show you what to do next. Okay, once you're all installed, let's go ahead and power it up by using the computer USB port, and the K30 sensor should light up. Let me turn the lights out so you can see. Yep, you can see the K30 sensor lighting up. The transceiver, RS-485 transceiver is lit up, and you saw the USB light up when I first hooked it up. So let's go back to GasLab. Here's how I set up the GasLab software to connect to my sensor. Come down here to port, COM4. For kit, I just select the FTDI default. I leave product blank for series, K series. It's going to default to the K30 1%, but I have the 10%. So do this one, 0 to 10%. I leave the name and the address alone. And I click connect. Okay, connected to the sensor. Now you can do a one-time read on the sensor with this button. You can do auto logging where you can set intervals and duration. But this is what I was most interested in, configure sensor. Click on that. Opens this window up. You can calibrate it to 0. If you have a standard of 400, you could calibrate it. But right here, automatic background calibration. The whole point of this video is to turn this off. Now, when mine was on, it said it was set to 180, which if I remember right, the Senseair said it was 7.5 days. That's what the ABC algorithm. So I think, 7.5 days times 24 hours a day, I think that's what that is, 180 hours. After I powered everything off and turned it back on, it said it was off. So I know it's been turned off, and that's awesome because now I don't have to worry about it. I'll put links below in the description to the various components and documents I use for disabling this feature. If you have any questions, don't hesitate to ask in the comments. I hope you enjoyed this video. If it helped, please like it, and if you want to see more of this, go ahead and subscribe. As always, may the Lord bless you and keep you. May the Lord make his face to shine upon you and be gracious to you. May the Lord lift up his countenance upon you and grant you peace. By the power of the Prince of Peace, Yeshua, amen. See you guys. Shalom.